Hey everybody, new lesson today talking about how to solve two-step equations. And the reason we call it two-step equations is because basically there's going to be two things that we need to do today to be able to solve the equation and figure out what our variable is. You can see I've listed here so far because I'm going to show you what we've done to this point. Alright, so far what we've done is we've learned how to solve equations that are one-step equation, and I'll give you an example of that. Something like x plus 3 equals 28. Okay, and this is called a one-step equation because there's one simple step that we have to do to be able to solve this. Now we could use mental math to solve this and say what number plus 3 equals 28, and we know that x is going to be 25, and that is, remember from our lessons I said that is going to be just half of the battle. So half of the work is just figuring out what the answer is going to be, getting a correct answer. The other half of the battle is we want to know the proper way to show our work. All right, so that's really what's important here. And if we were doing a one-step equation, our rule was simply this. All right, I wanted to get the x by itself, so I have to get rid of that plus 3. And what we learned was if I want to undo and get rid of a plus 3, I do the inverse operation, which was to subtract 3, because a plus 3 and a minus 3 cancel each other out. And then we said whatever we do to one side, we have to do to the other. Since I subtracted 3 there, I subtract 3 here, and that's how we were left with x equals 25. Okay, so that's a one-step equation because there was one thing that we had to do to solve it. We had to subtract 3 from one side, subtract 3 from the other side. There was one step we had to do to solve that. Okay, we also did some that had multiplying and dividing in it. So this is also a one-step equation. So a new problem here, 5x equals 25. And again, we can all use mental math and say 5 times what number equals 25? Well, x has to be 5 because 5 times 5 equals 25. But then we had to learn how to show our work. And what we realized was since this was 5 times x, I can get rid of a times 5 by doing the inverse, which was to divide by 5. And then we would do 5 divided by 5, which would leave me with 1x, which we just wrote as x. Okay, but since I divided by 5 on one side, I divide by 5 on the other side, and 25 divided by 5 is 5. And again, that's a one-step equation because there was one thing that I had to get rid of. Again, over here, there was one thing that I had to get rid of, the plus 3. Over here, there was one thing I had to get rid of, the times 5. And by getting rid of those things, we were able to solve this. Well, in today's lesson, we're basically going to be combining these two problems. So rather than just having one thing to get rid of, now there's going to be two things to get rid of. So here we go. It says now. Now we're going to have something like this. So if I just combine these two problems, you're going to see something like this, where I'm doing something that says 5x plus 3 equals 28. Okay, so there are two things that we have to get rid of here, because remember our goal. Our goal is to get the variable, in this case the x, all by itself on that side of the equation. So if I put my dotted line down here, that tells me I still have to get rid of this plus 3, and I have to get rid of the times 5. And it's no different than anything else. We still remember that I get rid of a plus 3 by minusing 3, and I can get rid of a times 5 by dividing by 5. The only issue is, which one do we do first? Alright, so if I get rid of this stuff, we'll just go back. Alright, we have to realize what do we do first. Well, order of operations, what most people will say is that we always do we do parentheses, exponents, multiply and divide, then add and subtract. But really what we're doing in equations is we're working backwards. So the rule that we're going to learn today is always the first thing that you get rid of, and I can write it down over here, 1. The first thing that we get rid of are always addition and subtraction. Then, after we get rid of any additions and subtractions, then we can get rid of multiplications and divisions, and that's the order. Okay, so when I see this plus 3 here, the plus 3 is the first thing I get rid of, and just the same as before, I get rid of a plus 3 by minusing 3, and whatever I do to one side of the equation, they cancel there, I have to do it to the other. And by doing that, now I rewrite what I have left, which is 5x is still left over there, because I haven't touched that yet, equals 28 minus 3 is 25. Okay, and just like before then, since I did my first step already, the subtracting 3, then step number 2 is to get rid of this times 5 by dividing by 5. They cancel each other out. Whatever I do to one side, do to the other, and you end up getting x equals 5. Okay, so two-step equations today because there are two things that we have to get rid of in order to solve this. Okay, two problems. I'm going to do example 1, And after you watch that one, then you guys can pause it and try example 2. Okay, so example 1, 3x plus 7 equals negative 5. So I'm going to put my dotted line down here to separate my two sides. Again, I know there are two things to get rid of. I have to get rid of that 3 that's being multiplied by x. I also have to get rid of the plus 7. Okay, my rule says I have to get rid of the plus 7 first. So I get rid of a plus 7 by subtracting 7. They will slash kill each other. They go away. And since I subtracted 7 from one side, I have to subtract 7 from the other. And now I rewrite everybody. So you got to get used to rewriting. I'm left with 3x equals negative 5 and a negative 7. My integer rule says the signs are the same. I add them together and keep the sign. So you get a negative 12 when you combine those. And once you take that first step, well, now we're down to a problem that we've solved before. All right? I have 3 times x equals negative 12. I get rid of the times 3 by dividing by 3. Slash kill. They go away. Divide by 3 over here. Leaving me with x equals, I have negative 12 divided by positive 3. Signs are different. Negative answer. X equals negative 4. Okay? Go ahead, pause the video. Try number 2 on your own. Okay, you should be back, everybody. Again, two things I need to get rid of here. I have to get rid of the divided by 2, and I have to get rid of the minus 3. Okay? Again, we always have to know just what do we get rid of first. In this case, we get rid of the minus 3. I get rid of a, let me put my dotted line here. Get rid of a minus 3 by adding 3, because that's what makes them go away. Since I added 3 on the left, I add 3 on the right, leaving me with, I still have this x divided by 2 equals 1 plus 3 is 4. Okay, now, to get x by itself, I still have to get rid of the divided by 2. I get rid of the divided by 2 by multiplying by 2, slash kill. Since I multiplied by 2 on the left, I multiply by 2 on the right, leaving me with x equals 8. Now, one thing that you can do, and probably want to get in the habit of doing, is checking your work. If I go back up to example 1, basically, here's my problem. 3x plus 7 equals negative 5. I'm claiming that x is supposed to be negative 4. So if I take that negative 4 and put it in place of there, the problem then becomes 3 times negative 4 plus 7, and that's supposed to equal negative 5. Well, 3 times negative 4 is negative 12. Negative 12 plus 7, sure enough, equals negative 5. So if you take the time and check your work when you're done, you'll always know if you have a correct answer. Same thing with example 2 here. It says x divided by 2. Okay, x divided by 2 minus 3 equals 1. Well, if I take this 8, I'm claiming that x is supposed to be 8, and I simply plug that in there. Okay, 8 divided by 2 is 4. And then 4 minus 3, sure enough, gives you 1. All right, so we know, because it worked out, we have a correct answer. Okay, same deal for example 3 and example 4. I'll do number 3, then you guys can pause it. Try number 4 on your own. Okay, so I know the two things I have to get rid of here. I have to get rid of that positive 7. I also have to get rid of this negative 4 that's being multiplied by y. Now, one thing I'm going to point out is this. I know I have to get rid of that negative 4, but because that is directly touching the y, that's always the last thing that I'm going to get rid of. The thing that is with the variable is always going to go last. So when I look at these two things I got to get rid of, that 7 is what I want to get rid of first. So again, I know that's a positive 7. I get rid of a positive 7 by subtracting 7. Okay, they go away. And since I subtracted 7 there, I subtract 7 on the right, leaving me. Now, I can't forget that negative. This is negative 4y equals 19 minus 7 gives me 12. And then we're down to a one-step equation. I can get rid of the minus or the negative 4 here that's being multiplied by y by dividing by negative 4. They cancel each other out. Since I divided by negative 4 on the left, divide by negative 4 on the right, and we get y equals positive divided by negative is a negative 3. And there we go. Again, if I want to check my work, here's the problem. 7 minus 4y equals 19. But if I plug the negative 3 in there, watch what happens. This then becomes negative 4 times negative 3, which is a positive 12. And 7 plus 12 equals 19. Absolutely, it checks out. So I know I got it right. Okay, you guys do example 4 on your own. Pause the video, give it a shot. Okay, we're back. Things we have to get rid of. I have to get rid of the negative 19. I have to get rid of the divided by 7. And I'm also going to have to deal with that negative sign in there at some point. So I know that since the divided by 7 is with the x, that's going to go last. So step number 1 is, let's get rid of this negative 19. Get rid of a negative 19 by adding 19, because they are going to cancel each other out. Whatever I do to one side, I do to the other. Negative 5, positive 9, the signs are different, so I subtract. 19 minus 5 is 14. 19 is bigger, so I keep the positive sign. So I get 14 equals. Then I still have this negative x over 7. Now I want to take just a quick break, because remember, I said in class the other day that there are 3 different ways to write a negative fraction, meaning if I had something like this. If I had something like negative 2/3, I can put the negative on top with the 2 like that, or I can take that negative and put it on the bottom with the 3. And sometimes it just kind of hangs out front there and you don't know, is it with the 2 or with the 3. Those fractions all mean the exact same thing. Okay, so back to the problem. When I see this negative out front here, I got to make a choice. Do I want it to be on top with the x, or do I want it on bottom with the 7? And what I'm going to say is, let's put it on bottom with the 7. So I'm going to rewrite the problem. This is going to be 14 equals x divided by negative 7, because now I know what to do with it. I know that I can get rid of a divided by negative 7 by multiplying by negative 7, and that way the negative goes away, okay? Because the negative times the negative is a positive. Since I multiplied by negative 7 on the left, on the right, I multiplied by negative 7 on the left. 7 times 14 gives me 98. A negative times a positive is a negative, so a negative 98 equals x. Okay, and there's our final answer, negative 98. Okay, next question. Last one. This one I threw in there just for fun, because obviously we're doing this work just to learn the proper steps, and then all of a sudden we get an equation like this, which is a little bigger, a little nastier. We just have to remember to take our time and simplify. Okay, so pause the video, try this on your own, challenge yourself and see if you can get it right. Pause the video. Okay, let's see who got it right. So again, what we need to start to get used to is we want to do any simplifying that we can. So if I look on the left side of the equal sign, I see a distributive property. So I'm always going to start by doing that. So I take the negative 5 times x, which is negative 5x. I also have to take the negative 5 times negative 3, which is positive 15. And then don't be afraid to rewrite. I'm going to rewrite everything else. So the 2x comes down, then I still have this positive 4 that comes down. I have the negative 32 on the right. Okay, combine like terms. I see a positive 2x here and a negative 5x here. Those combine to give me negative 3x. I also have 2 constants. I have a positive 15 and a positive 4, which gives me a positive 19. When I combine those 2 things, positive 19, I still have this equals negative 32. So again, just by doing what we practiced, distributive property and combining like terms, now I've simplified my problem into a 2-step equation, which, since we just learned this lesson, we should all know how to solve. So I get rid of a plus 19 by subtracting 19. They slash kill. Subtract 19 from the other side. And now rewrite. I'm left with negative 3x equals negative and a negative. The signs are the same. So I add these together and carry the 1. And we end up getting a negative 51. I get rid of this times negative 3 by dividing by the negative 3. They go away. Divide by negative 3 on the right. So I end up getting, I know a negative divided by negative is going to give me a positive answer. Is going to give me a positive answer. 51 divided by 3. I'm going to show my work up here. It's going to be 1 time, 2 left over. Okay, and I end up getting 17. And again, it's a positive because a negative divided by negative is positive. And there we go. Final answer. Hope you got that. Okay, good luck.